should be able to glean some good answers for that. So what I'll do is I'm going through, I'll say that section there are some multi-choice questions on that. So I can narrow down a lot of that for you guys to learn. All right? Rather than just kind of, oh, we've got a test tomorrow, I think I'll read over all Roger's notes. You can narrow it right down to the bits you need to revise. All right? I'm not saying that I won't make one up on the spot when I'm at home, just randomly put one in. I do that most years. I'll just go, well, that'll make a good question. Type, bang, it's in Moodle and it's part of the whole thing. But I can say that I've told Moodle to take 3 timber, 3 concrete, and 3 steel multi-choice questions. All right? So you'll get 9 multi-choice. Then there'll be some diagrams that I'll directly show you that you will need to learn from. And then there'll be other things to do with mathematical calculations, which a lot of you will do well in, because you know, obviously got mathematical abilities if you're doing engineering. Okay. What else? It might pay for me to log in while I'm yabbering away. Everything's pushed forward a week, as you probably have figured out already, because of the national exams in the first semester. The national, as in all the other polytechs, put pressure on Unitec and pushed our exams forward a week, which means we all started a week late, which means instead of being at week 9 at the holiday 10, we were at week 9. So you all by now know when the exam week is. So that means your results won't probably be the same week as everybody else at Unitec. So if you've got mates in construction or ballet dancing or whatever else people do here at Unitec, you know, their results may come out a week before you. Don't panic, it's just the way it is. We have an examiners meeting after your second week of exam. So while you're done your exam and you're all gone home and yay, we're playing Warcraft now or whatever generation Y or X or Z or whatever you are doing during your holidays. Some of you work, I know that. We are busy marking, and then we've got to go to this examiners meeting. So I will be holding back assignment 4 and the test this year to take into the examiners meeting. All right. The reason why I hold back the test is that, as you know, if you get your decimal point wrong, you get the answer wrong, right? Whereas if I go into the examiners meeting, they say, hey, I don't know, you end up on 49, and I get told to go back and find you a mark. I can go back to the test and go, well, you got that one and that one wrong, but you were only a decimal point out. We can give you half a mark, right? We got you over the line, that's fine. But if you found out about that and you were sitting that far away from an A pass, you'd be coming into my office going, knock, 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 I want 2 more half marks too, and then you'd be wanting it for the B pass and so on. So it's all kept under wraps. It's the way we do it. We try to get people over rather than the other way around. We don't go, hey, I don't like you, let's make you go from a 50 to a 49. You know, it doesn't quite work that way. A lot of things come into play, like they will say to me, have they been attending class, right? So if you haven't been coming along and falling asleep, or even with your blank face with a name on it while you're playing Warcraft listening to my Zoom sessions, if that's not happening, then your chances of being allowed to be lifted up from a 48 or a 49 start going downwards, all right? And believe me, we've had students that don't turn up to class. They put in SAC applications for every test, everything known to man, or they're not called SAC now, something else, whatever the new name is. And then they're left on 48, and you know they've been given raised and this, that, and the next thing, and so they tend to go, well, leave them on 48. That's the and of course all the lecturers are saying, well, in my class they did this, this, and this. All right, it's not like we don't talk. So that examiners meeting is really critical. Once we've got all the marks in, once that's all been approved, a subcommittee, which I don't belong to, then take a last minute look at things, and then the results are released. So that'll be hopefully exams. However, some of you might find out a little bit earlier because we have prize giving on the 10th of December, and they need to find out if you're going to be there, and that usually involves industry giving out a fairly mediocre prize, but to me it's nothing. To you guys it's like you've been given a house. It'd be like $500 or $1,000, and that doesn't come from Unitec, so don't start saying Unitec's fantastic. It comes from industry, and they really don't care about the money. They've come in to get you signed up with their company, okay? So you watch them come in every year. They give a big speech and hand out the cheque and shake the person's hand, and then they follow the student to their seat, and within minutes they've signed them up because they're looking for the best student in each subject to join their company. So if their company specialises in sewage, water design, that sort of thing, they're not interested in a draftsman. They're looking for someone that got the top mark in fluids and hydrology, right? Simple. Highways is the same. Most of their work contains that. If they have drafting jobs, but they're looking at general engineering as well, they'll be looking for the top civil and structural drawing award. Currently, the top mark this semester is a B-, so there's not a lot there to beat, guys. For those that are thinking of taking their foot off the pedal, that was semester 1. Can't tell you who got that. So if you get the top mark in this class and it's above a B-, then you'll be up for that. There is an award in this subject. This is one of the only ones that there's an award in the first year subjects. Usually they're the final year subjects, all right? And it's obviously something to put on your CV, isn't it? I mean, you win an award at Unitec, it makes you look pretty good, even if the person comes in and doesn't choose you for the job. And then they start targeting us lecturers, going, we missed out on that student, they already had work, is there anyone else you know? Okay, because they don't want 500 people in an interview, they want us to tell the names of some students that have stood out in our classes, particularly the drawing ones, because it's coming up to wanting the new cadets for next semester. So that's kind of exciting. The other thing is there's going to be some work coming up. God knows why they've decided to do it this week. We've had all of COVID and they've got all the holidays, but they've decided, hey, students are all back, let's go and poison them. Building, is anyone recording this? I've got to be careful what I say, I'll lose my job. The old trades building, which is, if you carry on right the way around, it's building 108, I think it's called, if you're heading towards kind of the other side of campus over there, is going to get a roof taken off that's made of asbestos. Now, I'm not a rocket scientist, but I've worked out that the westerly winds will blow it towards the hub, right? So I'm not overly keen on that whole thing. If you think COVID's bad, you get asbestos in your lungs and you're dead, full stop. So just warning you, keep away from that building. And the next, I'd say a demo would take, does anyone have building experience? I'm picking a week or two to get the roof off. With asbestos, just add a little bit of a side thing here. You can't just have a whole bunch of clowns pulling the roof off. They've got to be suited up like as if COVID's hanging around, and they've got to do it all properly and wrap it all up and take it away to wherever they dump it. So that's happening starting Monday, I believe. All right, so this is probably one of the best buildings to be in, 115. But the closer you get towards that area, that's not so good. I've had a chat with the union myself. I'm not that happy about it. I'd rather they waited till the holidays, but I'll just let you know that bit of news is happening. And obviously exams will be here on site. Timetable, I'll go over that in a second, so you'll know exactly what you do and don't need to hand in for me. and the final test as well when that's needed. I might just in the lab class do a bit of a sketch on the whiteboard for you, just to sort of, for those that are a little bit confused about what they need to do for their slab. You don't need a dimension on it, you just need the actual plan view. You don't need the sideways view, and you just need to show the bars. If they bend down, there needs to be a donut in that position where it bends down, looking down on it. If it bends up, the same thing. And you need to call them up as per the examples. I've had a number of students in this class ask questions, and the example of the CAD example there is pretty much covers a lot of things in terms of drawing it up. With the steel members, I've uploaded a slightly revised steel member for you. It's more for assignment 4, but make sure you use the revised one when you're doing your angle calculation. So if you haven't used the revised one, use that. A lot of the degree students are Googling these structural members and trying to get a quick answer on their weight and all that sort of carry on. It's not as hard as all that. If you start Googling things and the weight's different to my weight, you're going to get a different answer. And if the answer's different, you're going to get it wrong. Okay? So use mine. I can't tell you the answer, but the clue to the weight is actually in the universal column, the call up of the column. Okay? So that's the one you use. It may not be what's on Google, it might not be the European standard, the American standard. Let me explain, different grades of steel have different weights. So, you know, if you start involving Mrs. Google, you're going to go way off getting the right answer. One year with, I was stupid enough to show students that if you listed a continuous P line, you got the length of the P line. So they all drew up their bars, and then they listed it, and that was the answer they thought was the correct one, but the calculations were like 2 or 3 mils out. Because I was stupid enough to say that, and I didn't say it then, I had about 4 model answers to make up, and I had 4 different answers to mark the students on. I'm saying this, you mark it according to the calculations. Do not draw it up in AutoCAD, do not list it, because for some reason in AutoCAD when you do it, a fillet, it doesn't quite calculate the right length, okay? So don't do that. One of the bars is going to be a bonus mark if you get it right, and everyone's like, oh, which bar is it? Not telling you, but you will know. It'll be the one that you, all of a sudden, the handbrake goes on. Oh, the others are easy, that one's tricky, all right? So, I suggest maybe getting together in small groups and do the thing, come together and say, what did you get, bro? What did you, whatever, and have a good argument about it over who's right, okay? Don't be a lemming, because lemmings just follow other lemmings and they fall over the cliff, all right? There's a couple of things in there that I've purposely done so that the lemmings follow the lemmings, and a whole lot of them end up with 0 marks, all right? Best to both have a go separately and then crank it out. I know that goes on a lot at Unitec. You give me your assignment, I'll give you my maths one, you give me this, whatever. But at the end of the day, you will learn from this reinforcing if you have a go yourself, and else bells, you've got to do it in the test. That's part of the maths for the test. If you don't learn, that's right. I get students that get, 4 out of 5 for the reinforcing schedule, and I'm like, wow, they did well. Come to the test, 0 out of 5 for the test. Okay, so I'll go quickly over the timetable. I'll talk about timber as we're going through. I'll point out different things, and then please stop me at any stage if you want to. But you can ask me questions after that if you want to. All right. What I also wanted to point out was that Andrew, or Sosifo, I think it's Andrew, is running 2, he'll be in the labs. Most of your labs will have a past student anyway, but I think he's going to also run a Monday and Friday Zoom thing. that you can share your screen and catch up with them as well, right? And yes, the same rule applies this Friday, 4 o'clock's the cut-off for me, so up until then, you may email questions. I like the students that send me a question 1, 2 and 3 all at once. That's a lot better than the minute I reply to a question, I get another question, the minute I reply, that's like an email that won't stop. It's a lot better if it's four questions and then I'll just answer them all at once at some point, right? Right, let's get into this. Hope you guys have all voted already. I've already voted. I can't see that my opinion's going to change before Saturday, but quite like this voting early. There was one person in the whole building that I went into. Took about well under 2 minutes, something like that, and I was gone. Okay, so the other thing, of course, that I think you've all kind of figured out anyway. By the way, you should be marking yourself present up there before. Is there any issues with that at all? No. From now on, and you should have all been marked present for the first 8 weeks, or at least International shouldn't be chasing you because our boss said he's taking care of all that. 9 weeks actually. Okay, so obviously if I send an email out, don't English second language students, just be a little bit careful in reading what the email is, because if it says surveys only, I know it's tempting to go, oh, I'll be nosy and see what they're up to, but it's only interrupting you for half an hour when you don't need to be. And if I say engineers only, that's you guys, so you should read it. I try not to send out millions of emails, but when I do, they are important. So I know you get them on your cell phone now and it's easy to go, oh, what's that one, off, delete, but they are important, and that's it, you've blown your assignment, all right? So when I do, it is important. And I've separated off things. I think what's going to happen next semester is surveying is going to branch a little bit off from you guys. They're getting some big numbers already from all the people that have, I guess, lost their jobs and coming in. Getting massive numbers with engineers as well. So if you know what you're taking next semester, I would get in as quickly as possible and enroll for next semester, because there are students coming in that will have credits already that are going into some of the classes that you're trying to do, and the numbers are filling up really, really quickly, and they're trying to accommodate everyone. But I'd say if I was you guys, I would jump in there really quickly, because for example, civil and structural drawing semester 2 next semester is starting to spill into more classes, right? And the lab classes just aren't available, so they may just put a cap on that and say you've got to do something else. Do you understand? So, yeah, and the other thing is try and get qualified before those, that lot that are behind us come in, because they'll take all your jobs, I would say, because they, a lot of them already have degrees and what have you, and they've just been made redundant from their work. Good scare tactic. Right, the timetable, I was going to briefly have a chat about that, because it's been changing like the wind all semester. Where are we? Can you guys see that board? Not very well, I'll go and turn the light up. Yeah. So we're back to the old timetable really. This one here. You right? Almost? Bit more? Kill the guys at the back. Yeah, can you still see what you're writing? Right? Okay, so we've started this section here. Obviously you've had the break. So the ones that you really should be interested in turning up for lab-wise is next week's 3D. It's only 5 marks in the assignment. It is a bit of fun. It's a bit different. And if you have got time, you'll enjoy doing the 3D side of it. And it can end up being something that you'll use in your working life as well. The 3D demo is here under the lecture at the moment, so I may do it in here in this class. At this stage I am, but I might flip that and put it in the lab instead. But anyway, at this stage, it's next week, so try not to miss that one. You'll notice I've just used the word portfolio drawings. We're basically just going to be working through the drawings in the labs. But what I tend to do is have a wee spiel at the beginning and maybe write on the whiteboard. And if you're not in the lab, you kind of miss that. And that could be quite important for something in terms of your assignment. So you remember that this is about lectures, it's about whiteboard, it's about verbal, and it's about formal notes. Okay, so and maybe videos as well. Also, there's some self-directed study here this week after that, so no lecture. I'll mark you all as present in here, so you don't have to come along to this class on that week. I will send an email out. But you are expected, I will at that stage put some of the questions on Moodle, the mathematical questions, so instead of spending time in here, you are expected to spend your own time going over those questions and working out the answers. The following week I will come in here and I'll do the workings through of the answers on the whiteboard for the test, and so you are recommended to come in for that. But there will be some models put up on Moodle as well. And then you will be given the following week, instead of coming in here, which is week 14, I might add that as study week. So you are at home and you have other things to study as well, but you'll be studying for my test, and then we'll have the test during week 14 in your regular lab class. Okay, so is that okay? You understand? In here that week, not in here that week, in here the following week, not in here that week. So there's a bit of a mixture going on there. The lab classes will carry all the way through to week 14 when we'll have the test. Okay? With assignment 3, you are expected to start a new drawing. I don't want you to use your survey drawing. I want you to start a brand new drawing, file, new, ACAD, and away you go. Okay? Just before I start the class, I'll put in here reinforcing examples. So this first reinforcing example, is a plan view of a water trench, very similar to the one, the CAD drawing that's up there at the moment. Not a bad drawing, this plan view. No, it's a sideways view, sorry. This is a view looking sideways, elevation. Notice that we've got far face and near face, so the call up for anything on the side view of a wall is always near face and far face, or far face. This student hasn't quite done it right. These lines here, that should have been an open circle, and that should have been an open circle, all right? Also, the student has done a line down through number 7 and number 8 that is bad drafting. I will allow you to put the line down through the dash, any of the dashes, but not through the numbers, all right? So it becomes a bit like that game Tetris. You'll set your bars out, and then you'll have to move things around so that nothing clashes with your text. That's why you should make a good start on this, because believe me, you don't want to be doing that with like 20 minutes until hand, and you're just in a panic to try to make it work. It's a little bit like a magic jigsaw puzzle. There's also a few things like the circle not in the right place as well, but generally speaking, the student has done a fairly good job of this particular assignment. Example 2. This one is an enclosed trench. I guess it could be a sewer or something like that going underground. The issue here is that they have combined this drawing here with dimensions, and that's a big no-no in reinforcing. You don't have a drawing with dimensions on it on the reinforcing drawing. That is normally a separate sheet altogether. We draw something up with dimensions, and if we're going to do sections, we can put hatching and stuff on it. We never combine that with the reinforcing drawing. So he's also done a dimension across here. So the reason why I've done this is that those that don't turn up to the lecture will take one look and think they have to put dimensions everywhere, but you 40 odd people here will not put any dimensions on. Will you promise me, please? Some good notes here. You might like to have a wee look at the notes that you might think about using on the drawing yourself. Just another example of a schedule. What this student has done here is they've done a little picture, which is great, but they've got no dimensions by the side. You remember the class examples that you might have looked at, they had a number there that said what the dimension should be in each direction. The steel works probably missing a couple of columns, like the square meterage, and the plate should have a thickness column there somewhere at the moment. Just looking at it, it's only got a length and a mass, so it's not quite the way it should be. Today, when we talk about things, timber and stuff, you might like to look at this to see that, yes, they've gone a little bit further than just saying, a 10mm bolt. Alright, that's probably too far, but at the same time, this person has looked up on the internet or through my notes as well, what bolts are required. Notice down the bottom they didn't quite spell reinforcement correctly. This is an interesting one. This is for more assignment 4. What I wanted to do here was point out to you that when you do a detail is a blown up of something. It's a blown up view of something. A lot of students just do a circle like this with the word detail out to the side, and they copy the circle over here and it's the same size. Well, that's telling me nothing. Notice on the detail, now they've got their line type wrong here. The centre line type has not got that right LT scale. If you're not sure, print it out and have a look at your PDF. So we've got an LT scale here, wrong, but normally the actual drawing, in this case the drawing is drawn at, not quite sure, it doesn't, 1 to 20, same as you. All you need to do for all the bolts is just show a centre line. But over here, they've gone into more detail. They've done a circle, that they should have been centre lines as well. They've done a dashed line representing the hole that the bolt goes through, etc. So it's a different, you use different way of drawing up it in a detail to what you draw it up on your 1 to 20. I think these scales are 1 to 5, which is what you've been asked to do as well. Now you've got two choices when it comes to that. The one I probably recommend, but not the one we use in industry, but I recommend for students, is to copy, say you're doing this bit here, up the top. In model space, just copy that to the side. So 1 to 5, 1 to 20, it's going to be 4 times, right? So scale that by 4. So it'll go zoop, like that over here. That way, any of your text and dimensions and etc. will be the right height because you've already done the scaling in model space. So but the dimensions won't read the right number. So you'll have to right click on them and change the reading to 0.25. You know, like you changed when you did the long section and we distorted it, so we had to change the dimension setting to 0.5. This time I think you'd have to change it to 0.25. That's the way I recommend. The other way of doing it is you make a viewport over here and your viewport is set to 1 to 5. The problem with that is all your arrows and dimensions and text heights will blow up. It's like a magnifying glass, you've blown them all up. So you have to go through them all and change, or you do the calculation, okay, that's what my new text height is for the detail. Both of them work, both of them will get you full marks, but it's up to you on what you think when you do your details. They're worth 1 mark each, and I'm pretty generous with the detail marking because a lot of students don't bother. So I think the ones that do, I will go close to giving them 2 marks for doing a reasonable detail. You will need to put things in there like dimensions, the fillet symbol, the weld symbol, and a couple of other things, but yeah, if you're going to leave something out, it's not probably the thing you should leave out. Also, it's quite easy because you've got to draw it over here anyway. You can't get out of drawing this bit here, and so you're really just copying what you're drawing. That was in Mariah Meeting House, by the way, and that was probably back in 2013, so probably not far off due to recycle that again sometime if you come back next year. You might find something similar. Right, so timber notes. I see a couple of guys up the back have got their laptops. You should be able to open these up yourself if you can't see this thing very clearly. So what I do is obviously this week we'll only have the notes up to week 57, right? And then the 3D demo won't be part of these notes, but the revision will be. Okay? And eventually you'll get your own set of structural drawing notes which you can take away with you as a whole package. interesting, I was just thinking of these notes the other day with riveting here. I went over the Harbour Bridge to try and find that new strut that they'd put in there to keep it here, and the thing that stood out was, see all these little rivets? That every one of the struts there on the bridge had little rivets in it, except for the one. Otherwise I wouldn't have been able to tell. I was going fairly fast over the bridge, I suppose, but yeah, so if you're looking for that one, it's the one without all the rivets in it.
Is it bolts now? No.
Yeah. Yeah, bolts or nowhere near as many. Yeah. It's a different kind of shape too. It doesn't look that different.
Yeah, I was trying to find it today as well.
I know, you gotta be careful when you end up whacking into the side of your car or something, causing another accident and having a truck hit another one. That wouldn't be a very good excuse, would it? Why did you do that for, sir? Oh, I'm an engineering student, I was very interested in the new strut. Actually, the North Shore isn't exactly the right place to live these days, is it? I don't know how much longer that bridge will keep the capacity up. It was built in 1950 odd, and it was perfect for the, I think, 4 lanes. And then some clever bugger came up with the idea of putting the clip-ons on the side. But it was a sort of a temporary measure, which is now, we just drive over them thinking, oh, these will be lasting forever. But, yeah, if they don't end up making some sort of second bridge, that bridge there will end up getting to a point where it just won't work. So, or they'll have to take the clip-ons off. Have you ever anyone walked over it? It's like a trampoline when the big trucks go over the top. Interesting. Anyway, sorry, digress. You can talk about Usain Bolt too if you want to. Right. Okay. Right past it. Week 10 notes. A lot of you are doing materials this semester. Some of you have already nailed that and got that in the bag. Tick that box and moved on. It's a difficult subject because it combines obviously quite tricky things in terms of engineering terms and engineering products, along with, unfortunately for a lot of you, geotechnical terms, which are even worse, or geology terms. So it is probably one of the hardest subjects that you do, and I don't know why they decided to combine the two. It would have been nice if they combined them with something a little bit easier. But nevertheless, I can't avoid it because I'm teaching you how to draw, and when you draw something, it's going to have a materials component to it, okay? In this case, we're talking about timber. Now, I don't want to get into the kiln drying process and how long it takes and the air flowing over this, that, and the next thing, or the actual treatment process. I don't get into the different types of variations of treatments for tannalization in terms of how they differ when you're treating the timber. And I don't get into things like how to treat dry rot and all that sort of carry on. But I do want you to be aware of them for my subject, and they do make up good notes. And there are a few important issues that get taught by either Roger Glanville, Ingrid, or Intan that you do need to kind of regurgitate for this subject as well. For some of you, you'll be going yes because you were good at that. For others, it's like, oh no, not again. Okay, so moisture content. In building any structures to do with timber, it's really important that your moisture content reaches between 14 and 18% before you basically cover it up. So if it's inside and it's framing timber, you can't put your wallboard on until it's between 14 and 18%. And council come out with their little needle and their little reader, and they'll poke it in, and they'll go, nah, and they'll walk away, and that'll cost you $200 for the inspection, and they'll be back again in another week to test it. Meanwhile, nothing happens on the building site. So, to me, it needs to be a note on the drawing, so that everybody covers their backside. The builders read it, they know anyway, they've got their own product as well, so they generally won't call council until they're happy with their readings. You keep plumbers completely away from the site. My own building site, plumber decided what a fantastic idea to do a plumbing check a day before the building inspectors came out to test the water content of the timber. They flooded the basement of the new building completely, and the moisture content on the bottom plate went almost double with the water. It just sucked it up. It was so dry, it was like a sponge. And I couldn't believe it. The builder watched all this, helped him mop it up, and then called the council to come out for the inspection the next day. That was one of only 12 inspections that we failed at $200 a pop at the client's cost. So yeah, I've never forgotten that 14 to 18%. The other one is the 26 to 30%, which is basically timber you see in a timber yard after it's been raining for days and days and days and there's been no wind. It's totally saturated, and that moisture fibre saturation point is where timber won't stretch or anymore. Size-wise, it won't also be any heavier. Preservation treatment to me for insects and decay is important. So if you are going to treat your timber with anything other than your normal tantalise, it needs to be noted. I don't think we have an issue here, but if this building was, say, in the bush somewhere, in the native bush, where there'd be a lot more susceptible to some of the horrible little insects that eat our native trees, then I would definitely recommend some chemical treatments. But this is a building at Unitec here on a green site basically, so it will need to be tantalysed, and you need to take note of a few things coming up to how you pull the timber up on your drawings. So when you do the drawings, it's not just a case of copying my notes and putting it there and going, yep, finished, nailed it, 100%, and then getting all disappointed and angry at me because you get 40 or 50%. It's a case of putting some of these things down. It's not just a 100 by 50 timber. You're going to have to call up the grading on it. We'll get into that later on. The other thing is, with the timber, and I'll roll forward a bit more, is it a dressed timber, which is 140 by 90, and that's really smooth and able to be painted. There's gauge timber, which is your first attempt at planing the timber, or there's rough sawn, where the timber's just left as it is, all the burrs on it. It's a lot harder to paint and it doesn't look as nice. I would suggest it's going to be dressed timber, because it's probably going to be painted and that'll be sitting up there underneath the roof for all to look at. So when you draw it, you'll be drawing it 10mm less in both directions, but when you call it up, you're going to call it up as a 150 by 100 or 100 by 100 or 100 by 50. So the nominal call up is whatever the main numbers are, but when you draw it, you're expected to draw it as dressed timber. There's some common scales there used in civil engineering timber drawings. By the way, timber is not, in my experience in industry, you don't come across timber that much in terms of construction. Occasionally you'll get I don't like this word, but it's an architectural word, bespoke, which means an individually designed building with big chunks of timber beams in it, or to make it look good. But generally, if you walk around any building site in Auckland, particularly a double garage, because that spans about 6 metres, which is kind of, I don't know, almost from here to that other wall over there. If you have a look at the beam, it'll be a metal beam for sure. They generally are cheaper, easier to put in there, and they don't take as much space. They're only kind of that size in cross section, whereas a big timber beam across there might be that size, you know. So generally speaking, when we span large areas in buildings, they are usually steel members that are used. They're not that cheap. I said they're cheaper, not necessarily, but construction-wise it's a lot easier, and they can bury them in buildings and you don't even notice them. So, yeah, timber's probably quite a bit on the outer, not so much in America or in Alaska. I don't know if you watch that program on HTTV or whatever it is, Alaskan builds. They're always using timber, but obviously the timber's right beside them in the trees. They just chop another tree down for a beam. Quite different to in New Zealand. Now, when you are ordering timber for a job, the first thing you should do is exactly like steel. You ring up your supplier and find out what he's got or hasn't got. It's pointless doing a design in timber if, for example, we use 200s by 30s and there's none of them, because you're just paying for wastage and it all adds up on the cost of the job. Also, you may not want a 150, or say you're wanting a 125 and you had to go to 150. You may not want that. They might make it too deep and bang your head on it or something like that. I keep going back to the steel, the concrete beams that we put in Pak'nSave in Mount Albert. We got away with treble ties because it made the roof height a lot bigger. If we'd have gone for single ones, it would have meant that council would have made us drill more and more into the Mount Albert lava flow, which is under there, which was a very costly exercise. So it's the same with timber. There are lots of reasons why you don't want to end up going to another member that they haven't got. You guys are quite lucky. Every second or third year I do a truss, which is what a lot of you learn about in mechanics and structures, basic truss design, right? So I make you draw one up, and when I do it I put these things called split rings, tooth rings and shear plates on them. Shear plates are stopping movement that way on a truss, right? And the split rings give it some movement, and the tooth ring is like a giant claw which goes into the timber and gives it absolutely no movement in all directions, and it gets tightened up on the outside. But you're not going to have to draw that up this year, which is good, but there will be a question on one of those three in the multi-choice. Okay? Yeah, that's the first little clue. There will also be a question on the dry timber and the fibre saturation rate. Because I feel they're numbers you should learn off by heart. There's some more examples of fasteners for timber. These plates here are the most common one, because when they make the roof trusses, they tend to have a plate press which goes bang and basically presses them together on both sides of the truss. and it brings all the members together wherever they join. Framing timber, these Z nails, as I call them, are used for tying down the likes of bearers and joists to the piles underneath the house. They're also damn good if you don't like the boy racers that are driving around your neighbourhood, because no matter which way you throw them on the road, they always have one bit sticking up. But I didn't tell you that. Used to be a boy racer myself, but now I can't stand them. They're too noisy. The difference is that the boy racers now have got hotted up cars, but I used to drive right round in my mother's old Viva, and everybody used to look at me rather strangely. Now, when you're drawing up your timber, there are 3 different types of ways you can draw up timber in sectional view. Forget about everything that was told to you about in semester 1 with technical literacy. When it comes to timber, we define it quite differently. If I was to chop through a great big long piece of timber, then I would be doing it like the top one, a continuous member, a crisscross. If it was just a small piece of timber with a big piece on top of it, you got a small piece of timber and a big piece, the small piece would be called blocking. A good example of blocking would be down at the Auckland Viaduct, where you have little blocks and then another piece on top, and the piece on top they tie their ropes, the boats onto. So there's just enough gap between there and the wharf, right? So the blocking is always just a single line. And then you have dressed timber, and you draw dressed timber up very similar to that bottom one, like this. You've got dressed timber, so that's how you should show a sectional view. You're doing the sectional view, so it needs to be something similar to that, right? These are pictures of these medieval things that they torture people with. No, they're not. They're sideways views of the split rings and the shear rings. You don't need to know that at all. It's not part of the test or the assignment, and that's the ways that we show them, depending on whether we're showing an edge view or a face view. Now with timber, there are 2 kind of main other ways of fixing. One is nails and one is bolts. And so if we do have a series of bolts, we tend to show it with a dimension and then the number of bolts over a distance. With timber, a typical timber bolt would be something like this, a coach bolt, where that piece there stops the timber from going, the bolt from going any further. But I might add that with timber we generally put a washer. Washer is a circular piece of metal with a hole in the middle, the bolt goes through, and it stops when you tighten it up, it stops the nut from going into the timber.
So the difference between a couch bolt and a couch screw. Screw doesn't have the nut on the end, but you can use them for timber, both of them, right?
Yes, you can. Generally speaking, if you want something super tight,
Yes.
if the bolt, for example, is holding it really tight together, then you'll put a washer on. If it's just screwing, say, timber to timber, then you probably get away with it.
I'm moving to the next question of that assignment. It says couch screws.
You say coach screw?
Well,
It's not a leg screw, it's a coach screw, yeah,
But leg screws are couch screws, right?
basically,
Yeah.
yeah. So you're going through steel to timber, right? It's an angle. I'll draw a picture if you like.
Yeah, no, you wouldn't use that necessarily, because that top end is going into the wood. But
Yeah, this would be a wood situation where the timber is,
so we just pushed them
It gets pushed, yeah, it gets pushed into that point there, but I would also use this with well, there's a number of ways you could do it. You could recess it into the wood
Yeah.
and drill a slightly bigger hole. Or you could put a washer, that's what it looks like from the top, a washer in here, which would stop it from going any further. That is generally used in a situation like on decking, where you, or on a handrail, where you don't catch your hand on it. With a screw, of course, you could catch your hand on it as well, but what you've got in the assignment is a piece of a purlin like that,
Yeah.
and so it's coming through from this side,
From steel, yeah.
from steel, so it's going to stop, and it will actually protrude a little bit out of here. I think it's a
Yeah,
75.
it's a little bit longer, that's why I was asking.
Yeah. So, but it will be stopped by the steel. Okay?
Oh, so
The
it
use-
doesn't matter that it comes out now, really?
No. Well,
You can't see it anymore.
I'm saying it doesn't. You shouldn't be able to see it anyway, but I guess you
Ridiculous, like
you might.
smaller.
Yeah, but then you're not got the same strength, I
Oh,
suppose.
I get you.
Yeah. So, yeah, there's been a few students worry about that in the degree already. They get a bit funny like that. And I just said, just go with the flow. It's tricky giving everybody a license in the real world because students go off on a tangent and then I'm marking everybody's assignment differently. I've got a degree student that keeps on going, his father's an engineer, of course. He keeps on going home and asking Dad, and then Dad says, oh no, that shouldn't be sticking out, make it a 45. And of course immediately he's getting marked down by me. And he keeps on saying, oh, but Dad said. His dad's a traffic engineer, so that kind of explains everything. Whoops, I shouldn't have said that. Okay.
So you wouldn't use a nut on the end of that one? You don't need to?
You don't need to, no.
Well, a couch nut, but
If it was a coach bolt, you'd have a nut on the other side and
Yeah.
tighten it up. It's a coach screw, so it's going into the timber.
and the reason why we don't use the one with the nut is it doesn't need that extra.
I'm saying it doesn't,
Yeah,
but
yeah.
probably you would, the more you think about it. Yeah. It's all right. Here's your engineering bolt, which, and there's your coach screw, which is basically the lag screw, okay? So it's turned up on you. So that'll go into the timber, that piece, but like any other screw. And I would say, oh, you don't need a washer because the steel is stopping. Yeah. Okay, this spiral rolled nail, here's an example of different nails. Now, in about 2 seconds, I'm going to give a half a mark to one of my Pacific Island students because they're going to tell me exactly where they use spiral rolls and when and how and why. And now, anybody want to have a go for their half mark?
Talking about spiral roll.
The spiral roll one, yeah, I'm being biased here. I'm just asking the Pacific Island students where they might find one back in the islands where they would use that.
In their huts.
Okay,
Boat.
no one want to give it a go? Sorry? No, this is, are you from the Pacific Islands?
I was using the canoes.
Who's, wait, are you from the Pacific Islands?
I'll pick the bucket, I was
Oh, you've been, yeah, I've been to Fiji on holiday. Okay, I'll open it up to everybody. You were saying?
in their canoes, or their sailing vessels.
No? No? Anyone else suggest where and why I'm picking on the Pacific Islands and nowhere else? And I didn't say India or Pakistan or China or, no, actually China's probably, yep, you're gonna give it
Is
correct.
that because the
Their growth, they are generally more stronger.
That's what you're saying is correct, but it's not the answer I'm after. It's because of the cyclones, okay? And the cyclones tend to rip through the buildings, and the worst thing that you can have in a cyclone is the tin on the roof going around chopping people's heads off or whatever. And so they tend to put the spiral roll type nail in there, or a screw, to hold the tin down. And in fact, I've seen roofs with, everywhere you would normally put one, they put two for the extra strength, right? So in New Zealand, generally speaking, we don't get too many really bad cyclones hit New Zealand. So we might get winds of 120 k's or something like that, maybe 130, 40 if it's a really bad one coming through. But over there they'll get 200 to 250, and that sort of wind is what they need extra protection. Okay, so I wasn't able to give away a half mark. I'll go for one more. We have a few desperate students trying to edge them way closer to 50%. And it's actually, someone said the other day they call it an Excalibur nail, but I don't believe that. Where would you use a nail like that?
In the roof?
Last.
No, what did you say?
I think it's a plastic kind of thing, in which we just screw our nail.
It's not plastic, it's a steel nail.
Oh yeah, okay.
And sometimes they have nail guns that use them as well.
Oh, is it concrete now?
No. Oh, but it's to do with concrete. Desperate to give you guys half a mark, somebody. Not such a successful. I'll give you one more clue. It's to do with concrete, the stuff that holds up the concrete before you pour it.
Is it a boxing nail?
It is a boxing now, yeah. He's pretty desperate to get his extra mark today. I suppose we better give him his half mark. Have you already got a half mark for
Not for this one.
Oh, damn.
Oh, for three I do.
For three?
I think so.
Oh, if you have, then well done, you've stopped everybody else from getting it, but which I'm pleased about. If you haven't, email me before midnight tonight, or email me before then, and if you haven't got it, then you'll get it. If you have, well, bad luck to everyone else. Yeah, what happens is, when you're doing boxing, you remember back to my sketch of the concrete wall that we were making, and you had some temporary pieces holding it up, right? These pieces here are called boxing, along with that. So what you have is a nail gun that's loaded up with these things, and you put one of those in there, and there, and it'll go into the first one there, or sorry, probably more like that. And then that leaves this bit here sticking up. So then when you're finished with the concrete, you just go along with your claw hammer and pull that bit out, right? It's also often used on crates as well, where they know at the other end, like a crate that you're covering a car up, that you're shipping from, say, I don't know, India to Australia, and they know they're going to have to open the crate up when they get there. So it's a very quick way of taking nails out. So it's not even in here, is it? So that was a bit mean, wasn't it? So the guys at the back didn't even get that with their Google. Didn't even work. No. Okay. Guess what? Both those questions are in the test. So you're not going to forget that now, are you? Well, you won't. I'll be disappointed. Now, talking of the test, these two pictures are also in the test, and you'll get 2 from the bottom one and 2 from the top one. And when I mean 2, I mean you probably need to learn all of these terminologies. The reason is that in New Zealand, this is what we call things in New Zealand now. I come from the bottom of the South Island, a place called Dunedin, but it's not quite the bottom. The further down the bottom you get, that people start talking with, or they talk like that, you'll probably recognise some of them on the news. Whenever anything happens down there, they roll their R's with their tongue. Actually, China's got a part, I think it's northern China roll the R's as well, so there we are. It's not just New Zealand, but they also have strange names for things. And they call what we normally call a nog in the North Island is a dwang in the South Island, alright? And it's not the piece that's like that, it's the little bits in between the nogs or dwangs. So I know that a lot of you don't want to go past the Bombay Hills when you find employment, but if you end up down in the South Island, or you find one of these strange people that looks a bit like me, or we're all inbred down there of course, and they start rolling their R's and they go dwang, 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 that is what they mean, alright? I don't want any engineers to leave Unitech not knowing what a dwang is, right? DPC, damp proof course, that's kind of a little bit like sort of a rubbery, cardboardy stuff that sucks up the moisture so that the moisture from the footing doesn't end up in this timber bottom plate. The blocking is the piece between the bottom plate and the plate and the bottom plate is the blocking. All the other terminology you probably will find on Mrs. Google, but it's quite a good little diagram here because it points out the different things on a building site. And as engineers, the type of thing that might happen to you is you might be working for a small company and they say, hey, I want you to go and find the height to boundary. In particular, can you look at the fascia and the soffit and see if it's not going over the boundary? Now, if you don't know those names, you're sitting there going, fascia, soffit, and you know, you're busy going, yeah, I know what you're talking about in Google, right? But that is a very, very common thing to have to do. You could be an engineer on site that is going out to check something completely different, a manhole, stormwater, or even the edge of a concrete slab, and the framing's all up, and you get told, hey, can you get some survey equipment out and work out what that point is there? So with building, generally speaking, it's in Auckland, it's 2.5, and it's an angle of 45 degrees here. And this fascia of the building is not allowed to infringe that plane. And as an engineer, you might get sent out to do something different, but you're the only person there, you've driven 50 k's to site, and you get told by the boss to check the fascia and scotia, etc. Don't infringe they call them daylighting planes or height to boundary planes. So it's just a small example of knowing some of the building terminology, all right? And when you're doing building plans, you've got to draw up things like footings, foundation plans and stuff anyway. Up the top here is more industrial terminology. So when you've got like a barn or a large building, they tend to talk about things like the roofing material is sarking. They tend to have things like knee braces on the side of the large buildings, sheathing on the side, posts or columns, purlins, roof trusses rather than the previous building, and of course lintels and beams. So there'll be 2 from this and 2 from that. And what I've done is I've gone A, B, C, D, E, F, G right the way around, and I've said what letter is the top plate, or what letter is the dwang. Alright? So really, if you are going to stare at something before a test, these two drawings are probably quite good ones to stare at for a while, get your head around, alright? Every other year I also do a bridge. I think I did one in 2000 and, no, last semester, yeah. So when you do a bridge or anything with a deck, we tend to show these cutaway pieces like this, so that you can see the bearers and the joists underneath, alright? And I've put this in my examples, but you guys don't need to know that. It's just that if you've got these notes, you can refer to them if you end up having to draw a bridge or a deck or something like that in the future. And another example of how you do a detail, a circle with a line to another circle, it's just another option of how to do it. You can either do it the way on my example with a circle and a line saying detail A, and then underneath here detail A, or you can do a circle to a circle, depending on the room. Now, lastly, before we go, secondly, there's a question from, if I was to do from the grade down to timber preservation, down to there, there are two questions there, three questions, one about fungal, one about insect borer, and one about timber preservation. So if you read that very short page or page and a half, there are three multi-choice questions in that little small area. Now, I do have a bit of a fascination for the two-tooth longhorn New Zealand borer, which goes into our native trees. But you would be expected to know, for example, if that was the question, what would a two-tooth longhorn borer attack in New Zealand? The answer would be native trees, okay? Or saproots.
So what was that, two-grade policy to?
Two-tooth longhorn borer. Generally speaking, we try to treat timber before we introduce it to things like borer, etc. But most of you who will end up probably buying a second-hand older house as your first house, the chances are there's borer already in it, and you can treat it with borer bombs and other things. There's a paint that you can paint on as well nowadays. We let one of those things off and forgot to tell the fire department, which is a bit dumb. The neighbours were getting rather concerned about all the smoke coming out of the house. The timber treatment, these two charts here, there's another two questions on them. I'll just go over what they are. So Ingrid would have told you about the types of treatment for timber, or Roger Glanville, either or. Piles, H5 is the highest that they go to. You also have H4 piles as well. They tend to be fence posts. When we're talking about the lowest form of treatment, normally it's things like subfloor framing at 1.2. As this number increases, it's more likely, if it's got a 3 in front of it, that it's going to be exposed to the weather, like the framing of a deck or something like that. Whereas if it's down around the 1.2 mark, it'll be framing for the house, but it should only be exposed for, I don't know, maybe 2 or 3 weeks before it's all closed in, 4 weeks maybe, and then they let it dry. It has, so the mistake they made many years back in the 1990s was that a lot of that framing had no H rating at all, so it was immediately water was got to it, it would basically be susceptible to rotting. And then the second mistake they made was they didn't put a gap between the wall and the cladding that went onto the wall. Nowadays they have a gap, so they keep that any water that comes through the wall doesn't go straight onto the internal framing. But anyway, these are the different forms of treatment and examples of areas where they would be found. So a typical multi-choice question might be, I'm going to use some roof framing, and it will be within the roof, so once the roof's on, it'll be protected from the weather. Will I use grade 1.2, 2.4, H4 or 3.1? The answer would be 1.2, okay? And down here gives the comment section gives a lot better comments on the different grades, and they're in order as well. And as you can see, the more they're exposed to external elements, the higher this rating here becomes. Now, speaking of comments, on assignment 1 and 2, I made quite a lot of comments on your drawings. I was quite disappointed to find that the same comments were on assignment 2 as were on assignment 1, which means that either you didn't look at them, or you didn't understand them, or you just completely ignored them. It's really important to read those. I know we're doing structural now, but I mark according to those things that I pick up on your drawings. So if you don't understand something that's in the comments, during the lab class, you could ask me, what that meant. If you do understand what it is, you do know what you did wrong, don't continuously keep doing it, and you're likely to improve your mark considerably. And also at the top, if you read the comments along the top, it pretty much gives you an idea of how I've marked it. Okay?
What do you mean by CAD issues? It doesn't really explain that.
Okay, well, the
Is it like offsets?
it's everything you would have got pinged for last semester, right? So I could show you two drawings where a student has done the correct, got everything in the exact, both almost the same. So one student has got the design contours right. They've got similar notes on the drawing about the trees, the bushes, they've got similar notes here. This student here has cut off half his text in the viewport. They haven't started their leaders from the correct place. They've got different size text. They've got text on an angle. They've got all the things that Ingrid would have pinged you for in TechLab if you were with her, or me if you were with me. Some students here did TechLab with me as well. So they've got all those things that are carried over that look really awful. And this student's got all the trouble with nothing. There's no CAD issues at all. Very well set out, looks good. The difference between the two drawings is this one here might as well hang on grandma's fridge. And this one here is almost getting up there with a professional drawing, right? So if I didn't have a CAD issues negative mark, they'd both be marked the same. So if there's CAD issues there, that's my way of taking some marks off for sloppy drawing, unprofessional, and to be honest, it shouldn't have passed last semester, right? So it's a little bit like if you get asked 3x equals 6, and you do the mathematical calculation, but at the end you have to, I don't know, add on 3 plus 3, and it equals 5, which you've learnt in the previous version of maths. Yeah, so that's what I mean by CAD issues here. And usually most of them are explained, but I get a bit kind of, I've done a paragraph and I'm still seeing things going, "Grr." So if it's really bad, it'll be a mark off, or if it's not so good, if it's just picking up one or two things, then unfortunately it'll be hard for Monday. Yeah. The other thing that students do is they explode the title block, which is a huge no-no, and also they, the title block, you know, the viewport's wrong, all that sort of carry on, so I have to be harder on that at this level. It may seem harsh, but, yeah. Usually when I'm doing that consistently to students, and I will talk to Ingrid and she'll say, oh no, they probably shouldn't have passed technical literacy, but they ended up on about 47 and a 48, and I got told to go back and find some marks. And I'm like, what did you do that for? Another year would have been better. Yeah. Okay. So, if anyone else was listening to what I've just said, that is the reason why there is negative marks, because I can get two people doing two drawings that are identical in terms of what I'm marking, but they're just not anywhere near the same. If you see my example answers, they are actually adapted from students' work. Like I'll take a good student and I'll just fix it up a little bit more, and that's a sort of a professional drawing. And yeah, so even my ones that got 13 or 14 or 15, they're not perfect, but they're up there with where I want them to be. Yeah. Okay, I'll let you go. Are there any questions that anyone has just generally, apart from? No? Okay, so that's the end of your official notes. We'll do a 3D demo next week here. And if you decide you want to, I'm really flexible with the labs. If you've got homework you need to do something else in your lab, you're welcome to bring it in. Mark yourself present and carry on with another assignment from some other class. If you want to come in there and do mine and ask questions, Andrew and I will both be in there tonight and on Thursday.